Greetings, everybody. I want to go over the homework from our modular arithmetic, and I want to focus on the things that we really need is this calculation of the mod function. So that's why I call these the special problems. So the first one was, so A was minus 133, and then they asked mod. The modulus here was 133, the modulus was 23, okay, 23 plus. So remember, this function, it's a function with two arguments, but the value is again an integer, namely an integer necessarily between 0 and to what? 22, right? Remember, the condition for remainder is that remainder has to be less than the modulus and positive, okay? So that's one number, and the other number is 261 mod 23. But very often, I mean, each of these two numbers will be less than 23, but if you add them, it could be more than 23, so we have to take, again, the mod 23 if we want to stay within Z23. So in some sense, what we're doing is calculations in this collection Z23. Remember, these are the numbers 0, 1, 2, all the way up to 1 less than 23, 22. So we know our outcomes must always be in that set. Okay, so the two solutions. The first solution is the one that just following the suggestion. Now, I didn't do negative numbers in the lecture. I said often we don't need it, sometimes a bit confusing, but I do want to discuss them because we will need them. So, but the calculation is exactly the same. So we need to calculate minus 133 mod 23. Of course, we can use a calculator or an online app or online website that does this for us right away. But for now, I want you to show me all the intermediate steps. In particular, this involves calculating minus 133 div 23. That's always an intermediate step that has to be taken. Later on, when we have to do these calculations many times, and that is when we talk about cryptography and so on, then we will relax. I will relax this condition that you have to do it by hand, meaning using a simple basic calculator. In the sense that I'm now going to explain, okay, so step one, well, I have explained it already several times, right, but here it is. We take, first of all, to do the actual calculation, the long division, and that one we are a bit lazy and we allow ourselves to use a calculator, a basic calculator. So we divide this by 23, and the result is minus 5.78. I don't need to write all the digits out. There are more digits, but I don't. Step two, and this is important, is and this is where we calculate, right? This is exactly the part where we calculate the diff. As I said, this is the intermediate step, the division by 23. What we do here is we take the floor of this number. Now, what is the floor? The floor, remember, is, so here is your number, and then you look at the two integers in between which it is wedged, and the floor is the smaller one. So what does this mean for a negative number? And that is perhaps why I avoid a little bit negative numbers, because it might be a little bit counterintuitive. Here would be minus 5.78, right? But it's somewhere there, say, so here is somewhere 0. So what is this? This is negative 6, and this is negative 5. So what is the floor of this number? Well, the number that is just the integer, the whole number that is to its left, that is negative 6. Now, let's see. You might protest this. I don't like that. Doesn't sound correct to me. But let's see. Step 3. Give me the number that I want. Namely, remember, the condition is I need to end up with a number between 0 and 22. Okay. So what is the next step? You take your number you start from and subtract from that the quotient here, the diff value that you get, times the modulus that you had, 23. So let me color code them. This minus 6 is the one that comes here. The 133 is the original guy, right? Okay, I don't need to write that one. That's clear. And 23 is the modulus. That's the 23 here. No, perhaps let's color everything. And so this is my 133 that goes here. Okay? So what is that? So 23 times 6 is 138. Now notice there is a double minus, so it actually ends up to be it's 133 minus minus plus 138, which is 5. And this is a number in the set within the range. It is a remainder. So taking minus 6 was correct here. If you do the other number that you might have taken is negative 5, which is actually the ceiling of that number, but you would get a number if you do this calculation. I invite you to do it. You see your result is going to be a different number. This is bigger than, it's going to be actually a negative number. And remember, remainders can never be negative. Okay, so that's one solution. That was solution 1. Oh, no. Solution, okay, it is solution 1, but we only have calculated one number. We have to do now also, so this is, here we calculated the situation for the first of our two numbers. Then we do 261 mod 23. Okay, so here I'm going to do the steps a little bit quicker. First of all, I do 261 divided by 23. That is 261 divided by 23 is 11.3. That's 11.3. So then the 261 div 28, that's the number, that 23 is the number I can now calculate by just taking the floor of this number. Now it's simple, of course, 11. And then finally, this number is therefore equal to, we take our starting number, subtract from that our quotient, 11 times our modulus 23. What is going on here? I don't know what's going on. Some dirt on my iPad. Okay, so that is 261 minus 253. That is, as far as I can tell, 8. Okay, so seems like I'm losing my iPad. My stift here. Let me go out of here and go back in. Yeah, sorry. Let me I have to see here whether my no, look, oh no, Apple Pencil, so 61. I don't know why it is giving me a hard time. Okay, let's go back. Okay. Okay, here we go. We're back on track. Okay, so that's 8. Oh, that's 8. So where are we? We found that this number, I'll do it in a different color that you get to follow. This number we calculated to be 5, right? Yes. This number we calculated to be 8. Correct? So now we add them up, that is 13. And then we take 13 mod 23. What is that? Well, 13 is in the range, so don't even try to do this. You can, and it will work, right? Because if you would divide 13 by 23, the result will be a number 0 point something. The floor of that would be 0. And therefore, you subtract 23 0 times, you subtract from 13 0 times 23, so you get still 13. So this is the answer, 13. So this is one solution. But sometimes, as I said, I mean, this is perhaps not a good example. Perhaps the next one is better in that. The result might still be bigger than the 23. That's why we cannot leave this out when we want to calculate in modulo 23. But there's a second solution which is quicker and is exactly doing this. I say, well, let's ignore these intermediate steps here. Let's just calculate the sum of these two numbers. So solution 2. I have minus 133 plus 261. That is equal to, I'm not going to make, I want to be careful here. Is, oh no, that's not good. Yeah, 128. And now of this number, I take mod 23. And the claim is the result should be the same. And it is faster because I only have to do one of these calculations. So, okay, 128. Well, let's do 128 div 23 first, because that's what we need first. So I hope by now you know the order. So we do this, what was it, 23, right? 23, yeah. So what we need to do is take the floor of the actual division. So 128 divided by 23 is 5.5. and the floor of that is 5. Wait, what? Something is not right? Okay, so I made a mistake somewhere. I must have put a wrong number here. Okay, the result should be the same, and from miraculous reason it is not. That is 5, okay, and that is 261. 261, did I make 261 divided by 23 is 11.3. Yeah, so that is 11. 23 times 11, 253. Okay, and 261. Sorry, I'm double checking my thing. 8, no, that is correct. And 8 plus 5 is 13. And here, what do I do here? 261. I must be using a wrong number at some point, and I don't see where I'm doing this. Well, where am I using? No, I'm using 23 all over the place. Oh, okay, this is the diff. Sorry, sorry. Yeah, no, nothing happened, right? I was just calculating the diff. This is correct. Now comes the mod. 128 mod 23. For some reason I thought I had already done this now. No. This comes now. Now it comes. What you do, you take your number 128 and subtract from that the quotient you just found, 5, or rather the diff that you find, multiply with 23. So that is 128 minus, and that is 115, and there is your 13. Okay. For a moment I thought I was going crazy, but okay, here we are. So that's how you can do it in 2 steps, but there is advantage of both steps. The second one is quicker in this occasion, but the second step might be, the first solution might be better sometimes because the numbers are so big. It will not really matter that much for addition, but in the next problem that I assigned, multiplication, it does matter. So I'm going to go quickly do number 31b, because there you see how multiplication affects the size of things. So let's do this. So we have 4, 5, 7 mod, again, mod 23. Oh, thank you, because otherwise I'll get confused. And then multiply this with 128 mod 23. And we want to calculate what we need to, at the end, make sure that the result is still in our remainder set. So we did another times mod 23 when we multiply these numbers. Okay. So solution 1 is the one that you'll see works well, and the second one is going to be trickier. Works still, but you can see where the problem comes. Here, let's do the first one. We have to calculate this number. Okay, so first of all, let's calculate this number, diff 23. So that is, remember, you take the floor of 457 divided by 23. Go back to my calculator. 457 divided by 23, that's 19.8. So that is 19. And then 457 mod. Oh, let me just, I have it already written down. I'm going to save a little bit on space here. So this number, how do you calculate this now? You take 457, subtract 19, the quotient you just found, times the modulus, 23. And that is, well, 19 times 23. And so I have to subtract that from 457. So it is 457 minus 437, that is 20. Great. That's calculating the first of my 2 factors. Now the second factor, so now I'm going to this one. So I first calculate 182 diff divided by 23. Okay, so 128 divided by 23, and don't forget to take the floor. So 182 divided by 23 is 7.9, and then the floor of that is 7. So we can calculate this number as 182 minus, I hope you still have the formula in your head, right? So here is the color code formula. You take your number, you multiply it with the diff that you just found. You should, subtract from that the product of the diff you found. If it's negative, and the modulus that you start with. Okay, so you subtract from that the diff you find times the modulus, which was 23. So 23 times 7 is 161. So 182 minus 161, and the result, that is 11. No, and 21. 21, right? Yes. Yeah, okay, 21. So let's fill in what we have so far. We found that this was 20, and this was 21. Now you see, if I multiply them, I get definitely a number much bigger than 23, so I have to do it one more time. So now, what is 20 times 21? We have to calculate that first. 20 times 21, I'm not going to do it, it's 420. So we need to calculate, let's do it in black. We need to calculate 420. First, let's calculate the division by 21. That is 420 divided by 21. And take the floor. 420 divided by 21. Hela people, hela, 23, right? Don't send me in the wrong direction again. 420 divided by 23. Let's do this over again. Where's my erase thingy? 420 divided by 23 is 18.2. At the floor of that, so 18. And so now 420 minus 18 times 23. I still hope that you see where my formula comes from. So we do 18 times 23, that is 414. So that's 420 minus 414, which is 6. So the end result is that this is 6. So that's solution 1. Let's see how solution 2 would work. Solution 2 says, well, forget the intermediate steps of calculating these two values here. Let's just multiply these two numbers and then take mod 23. It's way much less steps. So that is, the two values were 457 and 182, right? 457 times 182. And that of this number, I'm going to calculate the remainder modulo 23. Okay, 457 times 182. Now, it is not an enormous number. It is 83,174. It is fine, but my calculator can deal with a number of that size. But now imagine that the sizes are even a little bit bigger. So imagine that this was a 5-digit or a 6-digit number, and this was a 6-digit number. If I multiply two 6-digit numbers, I get 12-digit numbers. Most calculators can deal with 10 digits only. And once your calculator starts rounding, it is impossible to calculate the exact values anymore, because rounding, you cannot round in this thing, right? If you have to calculate, let's see here, I have to calculate this modulo 15. I'm just saying something, right? Okay. If I round this up to 0, the result will be totally different by the remainder by 2. How much actually? This 2, because this is a million or 10 million, whatever, 10 million plus 2, and the modulo 15 of such a number. Where did this come from? No, I don't want you. Go away. If you take this number and you round it, you get a different result. You can check it yourself. So if these numbers get really big, then we need to do these intermediate calculations. Keep this in mind, because that's the technique that we're going to exploit later on. But okay, for now it is possible. So what would we do? Well, the first thing is to calculate the diff of this number. 83174 divided by 23. Okay, that is the floor of and that number divided by 23, that is 3616.2, so that is 3616. Let's see with these big numbers. We know that we kind of think we're okay if the result that we get here is going to be between 0 and 22. 3616 times 23. It cannot be 23, right? Okay. So that's why I said between 0 and 22. Okay. So what is this? 3616 times 23 is 8,000. So that is 8,374 minus 8,368, and the difference is 6. Oh, lo and behold, it's the same difference, and so everything works. Okay, but I want to emphasize that the second method becomes cumbersome if the numbers are really big, and that is also exemplified in perhaps number 33. I don't want to do all of them, so I'm going to do only one of them because the technique is always the same. So I'm going to only do 33a. I hope that's okay. And so what we need to do is 99 squared mod 32. Then that's a number, so we can square that number. And of that number, we take the remainder, but not 32 anymore, we take modulo 15. You might ask why, what is this good for? We don't know. It's just practicing. Let's just practice everything, okay? Okay, so, yeah, what I wanted to point out before, yeah, since the numbers 30, the two moduli here are different, what I was saying before doesn't make sense. But, so, before I do this question, suppose it was also 32 here, then I could use my second solution as well. So the moduli have to be the same. If the moduli is different, then I have no choice than using the first solution. But let's think about the second solution. Then I could take 99 square, so ignore the mod part, so don't take the remainder, then square this number, and then take mod 32. Now, it was not squared, but cubed, sorry, cubed here. So we have to cube this, so this would be cubed. This is 99 to the 6th power. That's already getting a big number, okay? Let's see what my calculator does if I do this. 99 to the power, I think my calculator does a power to the power 6, 2, 4, 6, 8, 10, 12. It gives me 12 digits, which I think it's the limit. I cannot put more on it. Some calculators only give 10 digits, so in some calculators will not even be able to calculate this number. And once your calculator is rounding, you know that you cannot do it that way. So that's why we have to, in these kind of situations, dealing with big numbers, we have to keep, each time you get a bigger number, say, let's reduce it by taking the remainder mod 32. So that at each single step, we are somewhere between 0 and 22. Okay? So now, okay, granted, this is not the actual problem, so let's go back to the actual problem where we really don't have any choice. Well, still, we have a choice here. See, I have to calculate 99 square mod 32. So I'm only going to do this part. So 99 square modulo 32. Again, I have two options. Again, actually, in just this calculation, as it is written, it seems like what you should do is 99 times 99. That is, so this is 9,801 mod 32, and so on. But I could also have done this and said, well, let's first calculate 99 mod 32, because, mod 32. And in fact, let's do that, okay? So I'm going to show you, do this calculation, see what we get here. Well, 99 divided by 32 is 3.09. So 99 div 32 is 3.09. So 3.09. So the floor would be 3. So we have that 99 mod 32. This number is equal to 99 minus 3 times 23. That is 69. No, 32, sorry. I'm still stuck on my previous number here. 32, that is 96. So this actually is therefore 3, right? Now notice that 3 is actually an easy number. So at the next step, what I did was I made an intermediate step. I calculated what this was. Then I calculate 3 square. So I'm replacing 99 with its remainder mod 32. And that is, as I said, something that we can do or up to not to do. If I opt to do this, then the next step becomes easy because now it's 3 square. So, okay, this was an intermediate calculation. Now, going back to this calculation, so that I can put an equal sign here, this is equal to 3 square mod 32, which is just 9. Right? There is nothing to do. 9 is small enough that it is one of my remainders. So you see, by doing this intermediate step, which was less in big number, I cut down my calculation, because otherwise I have to do this. Now imagine that you do not have a calculator. I rather than calculate this, because 99 divided by 32, long division I can do. This one, long division is not my forte, so I rather not deal with big numbers. But okay, let's nonetheless calculate it here. So let's see what 9801 div 32 is. And the whole point is that it is the same. I hope that by doing all these different ways of doing it, that you are convinced that you are allowed to apply this mod function at whatever time you feel convenient to do it, to keep the number small. Okay, so this is equal to 9000 divided by 23. That's 426.1. So if I round, this is 426, round down. So this means that this number that we were talking about, which should be 9, let's verify, 9801 minus 426 times this number, the modulus 32. Okay, you see the big numbers that I'm dealing with, right? Okay, you're saying, I have a calculator, what do I care? Well, in real life, when we use these things, we are talking about 10-digit numbers. The modulus itself will already be 10 digits when we get real cryptography, real implementations of this. And then, okay, then it becomes something that you don't really want to do. Okay, so anyways, this is, I don't know, let me do it again. I might have made a mistake, but because times 32, right? Oh, I probably did 23 again. Yeah. I must have made a mistake here. Sorry. Let me do the 9001 divided by 32. Yeah, see? The 23 is stuck in my head. Because it's a prime. I like primes. Although 32 is a power of 2. I like that too. Okay, so this was wrong. I put the wrong number in. That's, of course, something you have to be careful about. So this is 306.2. And so this is 306. Why did I stop? Because this number was negative. I know it shouldn't. So I know that for sure I was wrong. Okay, so what is the one? So this is the wrong one. I have to put in this number, 306. Let's hope that this time everything works out. 306 times 32 is 9,700. So that's 9,001 minus 9792. And so the difference is, lo and behold, 9. The same 9 that I found here. Now, I'm not done, right? Because the next step is, right, what I calculated so far, let me emphasize, this is what I've calculated so far. In 2 different ways, but I have calculated this number. Now I have to cube this number. So the next step is to take the cube of this number, that is 9 cubed, and then take mod 15. It's its own problem now. Notice that the first method where I reduce the 9, mod 15, is kind of moot because we are already small enough. So I have no choice here than to calculate 9 cubed. That's not really true either, but let's pretend that that's the only thing I can do. I'll say a little bit, what else could I do? 9 times 9 times 9, that is 729. So 729 mod 15. That's the number we are going for. And to do that, we take first 729 div 15. 729 divided by 15. Hopefully I'll remember that it's 15 and not 23. So divide by 23, no 15. Oh, and now I don't do anything, okay. 729 divided by 15, 48.6. So 48. And therefore this is equal to 729 minus 48 times 15. Let's see that everything works. 48 times 15, that is 720. That is 729 minus 720. The result is 9. Well, is that possible? Yes. Nothing prevents this from not being the case, right? 9. So that's the other solution I could do is I could break this down as 81 times 9 and then reduce 18 modulo 15. 81. If I do 81 modulo 15, see here I think already, okay, if I subtract 4 times I get 60, 5 times is 75. So 81 minus 75, which is 5 times 15, is 6. So this is the remainder modulo 15 of 81. So this is now 6 times 9, right? 81, I hope you follow. Let's do this in a different color. 81 modulo 15 is 6, because if I subtract a number of times 15 of it, I get 6. So I can replace 81 by 6. Now this number I can do by head is 54, and that modulo 15, okay, let me write it now in the here. Again, I can say, okay, if I subtract 3 times 15 is 45. So I have 54 minus 45, that is 9, and this is 3 times 15. So this is my answer. Yes, that's true. We also found it that way. So you see, you can play around a little bit with it. You can decide at any moment when you apply the modulus or not. You have to be careful in this case where we have two different moduli. You cannot confuse them, right? So at some point here, you had to take mod 32, okay, before we take mod 15. Okay, and then the other problems are very similar. This each time just different numbers, different moduli. So I'm not going to do them because otherwise it takes too long. All right.